Welcome to lesson 76 of algebraic concept, geometric patterns and tables. And this is the fourth in a series of lessons about sequences, patterns, and things of that nature. So what I wanted to tell you was that this is the fourth. We looked at geometric sequences before in our first lesson. And if you remember back, we said that geometric sequences or patterns deal with multiplication or division. And division is just multiplication of a fraction anyway. So multiplication and division are the same, just like addition and subtraction are the same thing. So let's get on with it. Here are our objectives. Here's our vocabulary. And as always, take the time to pause through this. This is the recursive formula. Here's an explicit formula. And you will be told when to use what. So write the first 6 terms of the recursive sequence. So you don't even have to use the formula for this one. Honestly, if your first term is 5 and you multiply by 3, you get 15. If you multiply by 3, you get 45. If you multiply by 3, you get 105. If you multiply by 3, you get 405. If you multiply by 3, you get 1,215. So that is our sequence. 1, 2, 3, 4, 5, 6. 6 numbers. Okay. I could have stuck it into the thing, but it really doesn't make a difference into the equation over here. But we didn't need it. Okay. Find A5, A10, and A60 using the explicit formula. And we give you the explicit formula. So here's our first term. Here's our common difference, or what we're multiplying by, our constant ratio as you would have it. So A5 equals 3 times 2 to the 5th power minus 1. So 3 times 2 to the 4th. 2 to the 4th is 16. 16 times 3 is 48. Equals A5. Okay, so let's take A10. A10 equals 3 times 2 to the 10th minus 1. 3 times 2 to the 9th power. And let's get our calculator out for this one. 3 times 2 caret 9, which is above the division symbol, equals 1,536. So a to the 10th. And then finally, a to the 60th. Or the 60th term of this series. So basically, we're just doing 3 times 2. 3 is the first term. 3 times 2 is 6. Then multiply that by 2 to get 12. And multiply that by 2 to get 24. Multiply that by 2 to get 48. And just keep multiplying. Just keep doubling it. So a to the 60 is 3 times 2 to the 60 minus 1, which is 3 times 2 to the 59th. And in our TI-84, we put 3 times 2 caret 59, hit enter, and we get a big number. And so what the calculator gives you is 1.72938. Not 79, 729. $729 and a bunch of numbers, but we're in high school. We're cutting it off to 3 numbers behind a decimal. E means times 10 to the 18th power. So that's a very big number. That means we had to move the decimal to the right 18 times. All right, so let's look at our third example. It says, write a recursive and an explicit formula for the sequence. So what is happening? The difference between 440 is we're knocking off a 0. So we're dividing by 10 or multiplying by 1/10. 40 to 4 is multiplying by 1/10, by 1/10, times 1/10. All right, so our common difference is 1/10. Our first term is negative 400. And so, how do we do this? So, what is our formula for recursive formula? All right, so a to the n equals 1/10, our common difference, times any a to the n minus 1. In our explicit formula, we need the first term. So let's do that. And then, so recursive is in blue, and our explicit will be in red. And so a to the n equals a1 times r to the n minus 1. So a to the n equals, what's our a1? Negative 400 times 1 over 10, which is our r, to the n minus 1 power. Okay, so we looked at that. And those were our 3 examples for this lesson. Please try to practice problems that are coming up next, and I will see you at the end of the video for a recap. Okay, write the first six terms of the recursive sequence. So we don't even need a formula here. So what you're going to do is take 0.0275 and multiply it by 10, because r is our ratio. So our first term is 0.0275. And when we multiply by 10, all you had to do is move the decimal point once to the right. So you get 0.275. Then we get 2.75. Then we get 27.5. Then we get 275. Then we get 2,750. 1, 2, 3, 4, 5, 6. And those are 6 terms. So take your first term and just multiply it by your ratio signified by r. And you don't even have to stick it into a formula. Okay, so now explicit formula. Using the explicit formula, and it's already set up for you. So 1/9 is our first term, and 2 is our ratio. So we're going to take a of 15 will equal 1/9 times 2 to the 15th minus 1, 1/9 times 2 to the 14th power. That's, I wrote 1/2. I meant to write 1/9. So let's put that in our calculator. We're going to type it in just like this. We're going to put the 1/9 in parentheses, then we're going to multiply by 2 to the 14th. So 1/9 in parentheses, 2 caret 14 equals 1820.4 repeating. So a of 15th equals 1820 with 0.4 repeating. Now I put the bar over there. Okay, yeah, let's use a different color for a of 25. A of 25 equals 1/9 times 2 to the 25 minus 1, which is 1/9 times 2 to the 24th power. And you put it in the calculator just like that. So a to the 25th, a 25 equals 1/9 in parentheses, 2 caret 24, and that is 1,864,100. Did that 4 not right? 135.1 repeating. So when you put this in the calculator, it looks like it's 111. But anytime you divide by 9, you're going to get a repeating number. So it does say 111 in the calculator, but understand that when you divide by 9, if it's not a 9, a multiple of 9, it's going to repeat. And then finally, a is 75. So this is going to be a big number. Equals, I should have did this in a different color. All right, so 1/9 times 2 to the 75 minus 1, which is 1/9 times 2 to the 74th. And 1/9, 2 caret 74 equals 2.098. If that rounds up to 2.1. E means times 10 to the 21st power. So when you get a number that says E21, that means times 10, and then the number behind the E is your exponent. So that's a very big number. Okay, write a recursive and explicit formula for the sequence. So we got 1/16, then we go to -1/4, then we go to 1, then we go to -4, and then we go to 16. So it looks like we're multiplying by -4. That is our D. Our first term is 1/16. So let's start with the recursive formula. The recursive formula says you take your D, which is -4. So any term n equals -4 times a to the n minus 1 sub 1. Okay, so that's recursive. So for explicit, we need our first term. So a to the n equals a1 times r to the n minus 1 power. So we get a1 is 1/16. I'll put that in parentheses, times r, which is -4 to the n minus 1 power. And that's a to the n. So those are our formulas, recursive and explicit. Maybe we'll get off into a different lesson of why you would use the recursive as opposed to the explicit. But I think that is a statistics question, and we might revisit the why and data and probability if that ever comes around in statistics. So I am going to leave the why for later, and I will just end this lesson here. So thanks for watching. Take your time and practice, and make sure you have some other problems to practice with. And I will see you on the next video. Subscribe if you like what you saw.